All right, so here we go, solving log equations, and we're going to do some simple ones. We're going to do these without a calculator, and we are going to make some domain statements before we actually solve these. Domain is, you should remember with logarithms, we need that the logarithm cannot have a number in the parentheses that's 0 or smaller than that. So right now, with this first log base 2 of x, I'm only going to deal with x's that are greater than 0. And the second logarithm is actually going to be a little more specific than that because I need x minus 4 to be greater than 0, which means that my values for x are greater than 4. You've probably never had to deal with domain other than just answering on a test, but for logarithms we have to watch our domain. This means when we do our algebra we might have to throw out some of our answers because they're not in this restricted domain. So when I get my answers here, they better be bigger than 4. So let's go ahead and condense this. We're going to do the skill that we learned last Friday, and that is condensing a logarithm down to one statement. You really want to have one logarithm for your equation. So I'm going to use the property of logarithms. It says if we have the log of a sum, I can turn that into the log base 2 of the product. So when this is condensed, this becomes x times x minus 4. I'm going to put brackets around that. Equals 5. That's that property from Friday. Now what we're going to do is we're going to convert this into an exponential equation. So we are going to take the base of 2 and we're going to raise it to the exponent of 5, and we're going to say this equals x times x minus 4. And I'm going to go ahead and multiply that out. And here we get to an equation that it's just a simple quadratic that maybe we can solve. So I'm going to get everything on one side of the equal sign. And I'll get x squared minus 4x, and then 2 to the 5th power, of course, is 32. Let's see if we can't factor this thingy. We've got the factors in negative 32 that add a negative 4. That's going to be x minus 8 and x plus 4. And then we set these both equal to 0, so we get our two solutions of x equals 8 and x equals negative 4. But I better be careful. Earlier I noticed that my domain was all values of x that are larger than 4. I cannot plug negative 4 into this logarithm because if I plug negative 4 here, I get the log base 2 of negative 8. And I would be like, what? I can't handle that. Anyway, so we can't do that. So this is a perfect example of you better check your domain before you go about and just blindly do your algebra. So my only solution to this is x equals 8. Okay, here I've got natural log of x equals natural log of 3 plus 1/2. And so what I'm going to do is I'm going to get the natural logs together on one side. And remember what I wrote on the very first page, we want to get one logarithmic statement. You don't want logs all over the place. It gets crazy. So I'm going to bring the natural log of 3 to the other side. And I'm going to keep the 1/2 there. Now here we have that property of logarithms that if I'm subtracting two logarithms, I can rewrite this as a quotient. And I wonder why I have a straight like L for that, and then I did a cursive L here. That's pretty weird. I'm sure that's some kind of personality disorder. So anyway, bring it over here. So I've condensed this logarithm in the natural log of x divided by 3. And now I'm going to convert this into an exponential equation. Remember, the base for natural log is e. So we're going to convert this into e to the 1/2 equals x over 3. And I'm trying to solve for x. And so I'm going to multiply both sides by 3. So I get 3e to the 1/2 power, which is the same thing as 3 square roots of e. Now let's look at our domain. The only thing we have to worry about here is that x is greater than 0. And e is a number 2.7, 1828, 1828, 4590, 45. Remember your Andrew Jackson story. But it's bigger than 0. It's a little less than 3 and bigger than 0. So this is a fine answer. Either one of those forms will work. Okay, again, sorry, that's fuzzy. That's a base of 3. Let's do another example here. What I'm going to do first is I'm going to divide both sides by 2. So I'm going to have the log base 3 of x minus 1 equals negative 2. And let's go ahead and write our domain statement. Our answer here has to be x is greater than 1. All right, let's keep going here. Now that I have one logarithm, I'm going to convert this into an exponential. So 3 to the negative 2 equals x minus 1. Of course, 3 to the negative 2 is 1 over 3 squared, and that is 1/9. And then I'm going to add 1 to both sides, and I'm going to get 10/9. And is that okay with my domain? Yeah, that number's a little bit bigger than 1, but it's still larger than 1. So that is my solution. Okay, so we're going to do this last example here. And this last example is it's a quadratic. It's a quadratic in disguise. That's a 2x. Sorry about that being fuzzy again. All right, so I'm going to show you how this is a quadratic in disguise. This is the same thing as e to the x squared minus 2e to the x plus 1 equals 0. Remember your properties of exponents. If you take a power to a power, you multiply. So 2x was e to the x squared. X times 2 is 2x. And this is of the form u squared minus 2u plus 1 equals 0. Remember when we did u substitution with solving harder equations? This is a quadratic equation that looks just like this. So this factors into u minus 1 squared equals 0. So this would factor into e to the x minus 1 squared equals 0. And so I'm going to take each factor and set it equal to 0. I really only have one factor here, and it's e to the x minus 1. So I'll add 1 to both sides and get e to the x equals 1. And you can think about this, how do I raise something to a power and it's 1? Do you know what number should go up there? Well, let's just go ahead and do the math to figure it out. I'm going to take the natural log of both sides, and I'll bring the x down in front. Remember, the natural log of e is just 1, and the natural log of 1 is 0. So my answer is x equals 0. So let's see if that makes sense here. E to the 0 minus 2e to the 0 plus 1 equals 0. Anything to the 0 power is 1, and I get a true statement. All right, there you go. So I will see you guys tomorrow.